All right. Solving by substitution. Think of maybe your favorite sport. If you are a basketball player and your point guard comes out of the game and you're going to make a substitution, who do you want to put back in the game? You. If you take a point guard out, you need a ball handler, right? Probably want to put a point guard back in. So now this is not the perfect analogy because not every point guard is equally capable, but if you take out someone who has the ball handling skills, you want to put in someone who has ball handling skills, right? Someone of equal value, in other words. If you take out the big man, the center, you probably want to put a center back in, unless you're playing some game. Here's a good one. If you take out the quarterback, you probably want to put another quarterback in, right? You need someone to throw the ball. So substitution, take something out, put something of equal value back in its place, okay? That is substitution. So we're going to be making some substitutions today. There are 3 steps to this. The first step, and you're going to hear me say this word a lot in the next few weeks, and that is to isolate, okay? What does it mean to be isolated? Alone, not be connected, by yourself, right? Isolate. So we're trying to get a variable completely by itself. It doesn't matter which one, but one of our variables needs to be alone, isolated, okay? Then you're going to take that isolated expression. So it's going to be like x equals something. You're going to take that expression, this portion, and you're going to plug it into the other equation. Okay, that could be x equals, that could be y equals, but we're going to take the back half of that, the part that's not isolated, and plug it back in, and then we'll find both of our solutions from that. So let me show you what I mean in this first example. This one says solve by substitution, and you have a system, right? 2 equations here. The one is 4x plus 3y equals 4. Does that have an isolated variable right now? A variable that is by itself on one side of the equal sign? No, right? Okay, so that's just making an observation. Look at the second equation. Does y equals 2x minus 7 have an isolated variable? Yeah, what is it? Y. Y is all by itself. That's what we want. As soon as you get a variable isolated, you take what's behind the equal sign with that. So you take this information, and now we're going to substitute. We know y is equal to that value, so we're going to take out y, and we're going to put in that value, okay? So let me show you color-wise so you can see where this is happening. So I'm just going to rewrite this equation, 4x plus 3. Now we're going to multiply by our y value. What is y equal to? 2x minus 7. Okay. And that will equal, now we're going back here, our 4. So we substituted what we know y equals in place of y so that we only have one variable, right? That's the goal here. You cannot solve an equation with 2 variables by itself. So we need to get the same variable by substitution. Now from here, this should be the easy part for you. We're just solving for x, right? What's your first step in solving for x here? Distribute. Okay, so if I distribute this, I get 4x plus 6x, and please don't forget to distribute to both pieces, minus 21 equals 4. Okay, keep going. 4x plus 6x is 10x. We're going to add the 21 to the other side. So we get 10x equals 25. This is creepy. This guy's watching me now. Sorry. Put that away. So then last step, we're going to divide by 10, and x will be 2.5. Okay? Now it says solve. When you solve a system, you're solving for both your variables or all 3 of your variables if there's 3. There are 2 here. So we just solved for x. how do we solve for y? We do the same thing. We substitute, right? We're going to take this x value. I know what x equals. Plug it in here. So y is 2 times 2.5 minus 7. So 2 times 2.5 would be 5. 5 minus 7 is negative 2. And we get a y value. Now, think about what that means. We're looking for a solution to a system. In the last lesson, we graphed it. What was our solution? In the last lesson, if the lines met? A point, okay? So your answer to this system is the point 2.5, negative 2. Your x value and your y value as a point. Questions on that? Yeah.
Why would we do that instead of graph?
Because sometimes graphing, like if you think about having to graph 4x plus 3y equals 4, that doesn't lay out very nicely. Like if I tried to put this into slope-intercept form, right, I would get 3y equals negative 4x plus 4, and then I would divide by 3. So I'd have to graph y equals negative 4/3 x plus 4/3. That's an ugly y-intercept, and then where you have to move with a third in there somewhere is just not ideal. So sometimes graphing isn't the most convenient way to do it. So then you have these other options, substitution, and then eventually elimination as well. So there's usually one that makes more sense. Substitution makes the most sense here because we already have an isolated y. It's just easier to set up this way. It's a good question, though. Any other questions on that? Okay, take a look at letter B. The first thing you should always ask yourself is, do we have anything isolated? So look at the first equation, 3x plus 4y equals 12. Is anything isolated there? No. Look at the second equation, 2x plus y equals 10. Is anything isolated there? Not yet, right? The x and y are together. The 10 is by itself, but we don't want our constant isolated. We want our variable isolated. So which equation is easier to get a variable by itself? The bottom one, right? Because this has a coefficient of 1. A coefficient of 1 is a beautiful thing, okay? All we have to do to isolate a variable is take away the 2x from both sides. So my new equation would be y equals negative 2x plus 10. Okay, so I'm looking at this equation instead of that one. So now my two equations are this equation up top and the red equation on bottom. Now we have isolation, right? Now y is by itself. So I can take this expression, negative 2x plus 10, and put it where? In place of the y, right? Because that's what y equals. So I'm going to take this expression, I'm going to take out the y, and I'm going to put in the negative 2x plus 10. They are equal, so take out the y, put in what y equals, and call it good. So it's going to be 3x plus 4 times negative 2x plus 10 equals what? What? 12, yes. Okay, so distribute this. You get 3x minus 8x plus 40 equals 12. So you get a negative 5x here. Let's take away the 40 from both sides. So you get negative 5x equals a negative 28. Okay, next step, divide by negative 5. Not a real pretty answer. You can plug that into your calculator, and if it's a decent decimal, go with the decimal. This one comes out to 5.6. Okay, so we're just going to call it 5.6. Okay, now you have options, but I would argue there's a best option. I am able, I'm going to undo this up here. I am able to plug my x value into whatever equation I want. So I could plug it in here, I could plug it in here, or I could plug it in here. Which equation makes the most sense to plug an x value into? The third one, right? You have the y isolated, so we just have to plug 5.6 in right here. It's not wrong if you do it the other way, but there's more room for error if you plug it into one of the others. So I say plug it into the isolated one every time, okay? Assuming you isolated correctly. So this would be y equals -2 times 5.6 plus 10. And when you plug that into your calculator or work it out in your head, you get a -1.2 for your y value. What is your answer?
5.6 -1.
The point 5.6 -1.2. Good on that? Good old substitution. Okay, you try C on your own then. So this is your initial setup. Figure out what you want to isolate. Well, if anything is isolated, if not, what you want to isolate. This one requires maybe one more step even. And then I'll walk you through it in just a minute. Coefficient is the number that comes before the variable. So if I have a 1 coefficient, like if you look back up to that last problem right here, that's the best set. Well, it's best if one's isolated, right? Nothing's isolated in that. So then the next best would be, do you have a 1 in front? Okay. On C, we don't have a 1 in front, but we do have a -1. -1 is your next best option because in the end, all you have to do is divide everything or multiply everything by a -1. So it's not going to change all your numbers again. It's just going to change the sign of those numbers. Did anyone come up with an answer yet for this? What'd you get, Henry?
6.2.
6.2. Anybody else get 6.2?
Oh, I got 5.2. I'm gonna go with
It is 6.2. Let's take a look at y. Okay, so for this top one, if I'm going to isolate my x, it's going to be -x equals, I'm going to take away 3y. So take away 3y. 0 minus 3y is just a -3y, right? So you can kind of just ditch your 0 there. But we're trying to isolate. So now get rid of, this is essentially a -1. So I'm going to divide by -1 on both sides, and I get x equals -3 divided by -1 is a +3 times y. Okay, so now we've isolated. I'm going to use this equation, and I'm going to use that equation. If I know x is 3y, where am I putting 3y in this equation? After the 3. So you're going to go 3 times, and then our x value, 3y, plus 4y equals 26. What's 3 times 3y? 9y. So this is 9y plus 4y equals 26. So 13y equals 26. And then divide by 13. So our y value will be 2. Okay. When I go to plug this back in, does it make the most sense to go here with it, here with it, or here with it? First, second, or third?
Third.
The third one, right? Plug it into that third one. So 2 in place of the y right here means x is equal to 3 times 2. So x is equal to 6, which means my answer is x value of 6, y value of 2. So the point 6.2. Any questions on that? Okay, last one. A little word problem for you. It says CDs at a store. CDs. We need to change this question. There are not CDs anymore. What should we call it? Albums on whatever. iTunes. Cost $15.49 each. Do you guys even know what a CD is? Yeah? Are they still around? Yeah? Eh. I have a CD port in my car. I can play a CD. Anyway, compact discs, CDs. I was around for tapes. Do you guys know what a tape is? Yeah? Oh, good. I was not around for what was the one before that? An 8-track. You guys know what an 8-track is?
No, I'm lost.
They were like super chunky tapes. What?
Do you know what a floppy disk?
Yes, I actually was just talking to my husband about floppy disk yesterday. I totally know what a floppy disk is. Do you guys know what a floppy disk is? Yeah? Oh, makes me feel really old. Anyway, what?
Do you know what Spotify is?
I do. I know what Spotify is. I don't know what a lot of the other things you guys do, but I know what Spotify is. Although I'm getting all caught up on Be Real and all the things. Oh, no. No, I don't have it. I just know about it. I don't have any of it. I have Instagram. That's the extent of what I have. I don't have Snapchat. I don't have Be Real. Is the best one?
No, I'm kidding.
I think it's the worst.
Be Real's good. It's fun.
I think it causes so much unneeded anxiety in people. It's like, I have to take my picture right now. I just got my note. Can I please take a picture? Like, no.
I haven't taken mine in like 3 days. I keep forgetting.
Yeah. It's stressful. Why do you guys put that stress on yourselves? Anyway, got a little sidetracked. CDs, compact discs, cost $15.49. Okay. Online, you can get them for $13.99 and a $6 flat rate shipping. What is a flat rate? One-time fee, like $6 for shipping, $13.99 per CD that you buy. Okay. So it says set up a system. X is the number of CDs. Y is the cost. Find the number of CDs when the cost will be the same. And what is that cost? So C, if you can set up a system is how many equations? 2 or more. Okay. So see if you can set up a system of equations. I'll tell you it is 2 equations in this one. See if you can set up 2 separate equations for the cost of X CDs. And then see if you can solve that system of equations. I saw several correct systems. Give me one of the equations that you would use here. Cost equals what? 15.49 times the number of CDs. So that's one of your equations. Your other equation, y equals what? 13.99 x plus that $6 flat rate shipping. Okay, so if we're going to do substitution, you always have to isolate first. Have we isolated? They're both isolated. These ones are lovely because now what you do is you're essentially just setting them equal to each other, right? This would replace the y here. So we're going to say 13.99 x plus 6 is equal to 15.49 x. So solve that. Take away the 13.99. Okay, so we get 1.5x is equal to 6. And then divide by 1.5. And you get x equals 4. Okay. What's y? What is the cost? It says find the number of CDs when the CDs will be the same. What is that cost? So you're plugging that 4 in for your x. So 15.49 times 4 is equal to $61.96. Tell me what that means. What's the number of CDs when the cost will be the same? 4 CDs at a cost of $61.96. Okay, so just make sure word problems, you're telling me what your answer means. I need to know that you understand the content, okay?